Multiplying complex numbers. Notice I have each one of these numbers are complex because I see that they have a real and an imaginary part, both of them. And when I multiply them, I multiply the same way I multiply binomials, and kind of look at that I as if it were an X. But there's a little trick to it here. So 2 plus 3i and 5 times I, or 5 plus I. And then I realize this box is 10. That is 2i. This one is 15i, and this one is 3i squared. But I have to remember that 3i squared is the same thing as saying 3 times the square root of -1 squared, which is 3 times a -1, which is a -3. So that's always going to happen in this kind of situation if I'm multiplying two numbers that each have a imaginary part. So now I combine the real parts. I got 10 and a -3. That is 7. And then a 15i plus a 2i is 17i. All right. Moving on. We're going to look at raising a complex number to a power. So let's say I had 2 plus 3i quantities squared. Well, remember, what this means is 2 plus 3i times 2 plus 3i. Once again, I go to the boxes. You might be able to FOIL or whatever works for you. 2 plus 3i, 2 plus 3i. So that's a 4, 6i, 6i, and this one is 9i squared. But remember, 9i squared is the same as saying 9 times the square root of -1 squared, or 9 times a -1, which is -9. So 2 plus 3i times 2 plus 3i, add together the real parts. 4 plus a -9 is a -5. 6i plus 6i is 12i. We can take it one step further. Let's say I had 2 plus 3i cubed. Well, we've already figured out what 2 plus 3i squared is, and that's -5 plus 12i. We just now have to multiply it by 2 plus 3i again. So I got -5 plus 12i and 2 plus 3i. So 2 times -5 is -10, 24i, -15i, and 36i squared, which I'm just going to make the statement. It's a -36. So now I can add the real parts. -10, -36 is a -46. Add the imaginary parts. 24i minus 15i is plus 9i. And that is 2 plus 3i cubed.